You'll see that today's aim says we are going to define and recognize examples of and non-examples of identity and inverse properties. This is very similar to the aim that we had yesterday. Yesterday we were just working with different properties. Today we're going to learn about the inverse and identity properties, which are properties that you guys don't have any background with. However, you pretty much already know about inverse and identity properties, and you've probably used them 1,000 or more times before. You just didn't know it. So, we're going to start by watching a video. The video is going to give through some of the information over here on the left-hand side. Then we're going to look at some examples on the right-hand side. This should only take us about 3 minutes because you should simply be reading to me what you have already written down. What is the property of identity? Jacqueline? Perfect. An operation that does not change a number's value. What about the additive identity? Purvi? Perfect. Let me catch up. Adding 0 does not change the value. Somebody give me an example. Kevin.
500 plus 0.
500 plus 0 equals?
500.
500. Now, if I wanted to make this more general, I could replace that 500 with any number. A plus 0 is going to be equal to A. Multiplicative identity. Bijan.
I believe times 1.
I'm not looking for an example. I'm looking for a definition first. Evelyn. Multiplying by 1. What happens when we multiply by 1? Yeah, it does not change the value. Perfect. An example, please. Nafisa. 600 times 1 is equal to 600. If we wanted to make this more global, in other words, make it work for something that represents every number, Oscar?
A plus 0. Times 1. My bad.
Okay. Inverse properties. What are inverse properties? Mr. Posey. Yes. Multiplicative identity. Yes, sir.
What if you do something like negative 8 times negative 1? Is that the same thing?
Negative 1 is not the same thing as positive 1, so negative 1 is not a multiplicative identity element. So we cannot use negative 1 instead of 1. All right, inverse properties. Andrea. An operation, I really like the way you said that. An operation that is done to reverse another. Additive inverse. Mr. Spinoza.
To subtract, or
Somebody ripped the dagger out of my back.
Or to add by a negative integer.
Okay. Or to add not by a negative integer, because if we already have a negative integer, we don't want to add another negative integer. We want to add the Opposite. Good. So additive inverse, adding the opposite.
I still wrote it down.
Yep. Example, please.
L-Pex.
Anybody? Anybody?
Kobe.
Genesis. What? Did you say minus? That sounds a lot like...
Subtract!
Relax. Let her fix it.
He must not be named.
5 plus 2 plus negative 2 is equal to 5. All right. So here we have additive inverses. I'm just going to box it so we're clear. These are additive inverses. They undo each other. They reverse each other. Multiplicative inverse. There were 2 ways that I was okay with you describing this, but you must be able to describe it both ways. Pervy. Okay. Dividing. Or multiplying by the reciprocal. Examples.
I'm gonna eat it.
Mia. 5 times 7 divided by 7 is equal to 5. That is one example. Somebody give me a different example. Pervy. 15 times 1 over 15. Here we see that we're using that idea of reciprocals. Okay, so really quickly, just as a reminder, reciprocals are what?
Opposite.
Whoa, opposite in math means positives and negatives.
Reciprocal.
Shh, reciprocals are what? How do we describe a reciprocal, Mr. Posey?
A reciprocal is the second part of a division problem.
Somebody help clarify. He's saying, what's flipped here?
Second fraction.
It's a fraction that's flipped over. So in this case, we took the whole number 15, we made it 15 over 1, so it was a fraction, then we flipped it over. That's how we multiplied by the reciprocal. All right, so let's look at some examples over here. But before we do that, we want to talk about that very important concept, that very high-level thinking concept, Mr. Matlock. We want to think about what is the link between inverse properties and identity property. Andrea.
When we multiply additive and multiplicative that word number by its reciprocal, we get an additive.
So I hear you saying when we do, finish, let's see if we can finish this soon. When we do inverses, what happens when we do inverses? Andrea, finish the sentence. When we do inverses. We get, I'm summarizing what you said because you were talking about both additive and multiplicative inverse, so I'm just lumping all the inverses together. We get an identity property. We get an identity element. So if we go back and we think about this idea, when we did this inverse, 2 plus negative 2, that really added up to 0. That's the additive identity element. When we did this 7 divided by 7, that's really just 1. That's the multiplicative identity element. When we did 15 times 1/15 times its reciprocal, we got 1. That's the multiplicative identity element. So when we do inverse operations, it leads to an identity property. Okay? That's how we use it every day in our work. So for example, the way that we use this in a problem, we oftentimes will say something like x plus 5 is equal to 10. And our next step is to x plus 5 plus negative 5 is equal to 10 plus negative 5. So we used an inverse property. 5 plus negative 5 added up to 5 plus negative 5 added up to 5 plus negative 5 added up to 0. So here we can see in work. So we see here, right here in our work, we have an additive inverse that led to the additive identity, the plus 0, which our next step is to go, oh, x plus 0, additive identity, that's not going to change it, that's x. And that's how we solve equations. So we use these properties all of the time. We just need to be able to describe them and know why we use them. Yes, Mr. Ross?
Yeah, that part doesn't really make any sense.
I can't see it.
Like, how you can just, like, box in 5 plus negative 5 and 0 and the x is 5. How does that work?
So this was using some equality properties. We added the negative 5 to both sides. So this was the 10 plus the negative 5. So that's not really related to the work that we were doing with the identity and inverse property over here. Okay? All right. So for each example, in one sentence, we want to state what property is being represented, and in another sentence, state how you know your answer is correct. What property is being represented here in the first example? It's a little bit tricky. You have to think critically about this problem. Jacqueline, what do you think? She says multiplicative identity. Jacqueline, explain to me why you think this is multiplicative identity. Okay, she's telling me she recognizes this multiplication of 2 over 2 is the same thing as multiplying by 1. So, this is the multiplicative identity because multiplying by 2 over 2, multiplying by 2 over 2 is the same as multiplying by 1. And does not change the value. So, you use the identity property every time that you change a fraction's denominator. You multiply by 1 over 1, you multiply by 2 over 2, 3 over 3, 4 over 4, to change that fraction to have a different denominator. And all you're really doing is multiplying by 1. You're just changing what it looks like, but you are not changing its value. That's why we use the identity property that way, is because we want those fractions to have the same value so we can subtract them. We just need to make sure that they have the same number of pieces. All right, looking at the next one, it says, complete each example given the property that it represents. So first of all, we should identify the property being used here. Which property is being used in this example? Mia.
The adding one.
There are two adding ones.
The one where you add the opposite.
The one where you add the opposite. Go back and look at your notes. What do we call that? Oscar, help her out.
It's the inverse property additive inverse.
Yes, this is the additive inverse. So she sees the additive inverse here. We're adding 2y and its opposite, negative 2y. When we add 2y and negative 2y, when we add additive inverses, they add up to what? Hervey. 0. So this is really 3x plus 0. These are the same thing. Okay, state whether each statement is true or false. Tell which property you use to determine your answer. So looking at this next one. Let's start with which property are they trying to show here? Yang.
Multiplicative inverse.
And how did you know it was multiplicative inverse?
Because 1 over 4's reciprocal is 4 over 1, and then it is simplified into 4.
Okay, so he's looking at these two things. He's changing them both to fractions and recognizing that these are reciprocals multiplied together. So this is a multiplicative inverse. The next question is, did they appropriately apply the multiplicative inverse? Kip yes or kip no? Give me a kip yes if this is true, a kip no if this is false. Everyone should be participating. Everyone should be participating. Yes, they did this right, because this would give us 1 times x. So they've kind of actually gone an extra step and used the multiplicative identity here. Okay?